In the previous session, we spoke about initial fundamental plasma, which was called neutron. When a neutron decays, it creates a proton and an electron. But as the same as any other atomic structure decay of heavy elements like uranium, new and lighter elements are created, but of the same characteristics of having the same number of protons and the same number of electrons, two new elements. The same thing happens to initial fundamental matter or plasma, where when the initial fundamental plasma decays into a proton and electron carries part of the matter. Electron still carries part of the antimatter. Electron still carries part of the dark matter. At the same time, electron carries part of the field forces within the plasma of initial fundamental plasma. So, for the first time, we explain that electron is a plasma, and actually, when it comes to the motion of the electron around the proton, we see clearly why the two components atom are made of the same materials and are made of three different matters. So for the first time we see plasma of a proton and the plasma of electron. And interesting enough, in the real world of physics, a lot of scientists speak about the random motion of the electron around the plasma of the proton. But in reality, now that we know that proton and electron are made of the same material, same composition, it's very simple why electron has a motion in respect to the proton itself. It's very easy. You have, for example, a condition when the electron side of the matter magnetic field comes close to the antimatter magnetic fields and the magnetosphere. So what happens? It gets pulled close. They are both dynamic. They move. In the motion, it gets pushed away. What happened? The antimatters, the same strength. It moves away. The same thing happens. The plasma moves further in and further out. They are both dynamic. But the system is very clear. The matter within the proton, the matter within the electron keep certain magnetic fields and gravitational fields in respect to each other. And where it's stronger from the proton side, the electron comes closer, but it cannot come any closer than what the total magnetic field sphere of the whole matter, all the matters of the plasma of the proton, allow the plasma of the electron to come close to. So now we see how electron finds its position. But because they're both dynamic and the whole thing moves around each other, very simply is as we look at this. That's an electron, that's a proton, and what happened? Electron finds its position, it comes close. Too close, it gets pushed away. And the motion is erratic. It's very simple. Now, what happened? Matter, antimatter, two antimatters find a position. Moving, they have to find another position, so it moves away. So the proton comes somewhere else, it has to come closer. So what happens? No fuel is burned. Only magnetic field's positioning allows the motion of the electron around proton. And this is what we have discovered, and that's what we have developed, and that's what we use, and that's what all the celestial bodies in the universe use for their motion, for keeping distance, for getting closer. So what we have developed is the same. We have developed a reactor which is like a proton, and at the same time we have the Earth. What happened? We create magnetic fields which are weaker, like the material of the matter, magnetic field of the matter. So we come closer. We produce magnetic field strength in the level of antimatter, for example. We move further. We haven't burned any fuel. All we did we use what we call gravitational positioning. When you call anti-gravity doesn't exist, because by law of physics, where there is a magnetic field, there is gravitational field. So we call it MAGRAV, which is magnetic gravitational field forces. So we work on a MAGRAV basis. Magnetic fields push two objects away from each other. Gravitational fields pull. We want to get closer, we change the strength of the gravitational field. We want to get further, we increase the magnetic field. So the motion is controlled, the height, the positioning is controlled by simply controlling the strength of the magnetic fields within the reactor. And that's what I call the universal method of motion. At the same time, once you understand you have a magnetic field, what we call magnetosphere around the planet, you can now control the strength of the field. Increase it, reduce it, that's what we do. So when we increase it beyond the boundary of the reactor, these are the reactors, very simple. You can see, this is one of the reactors which has been tested. So the concept was that half reactor is much better for vertical takeoff. It does work. Originally, we tried the full reactors. These are very hard to control. We do not understand the concept. Hopefully in the future scientists will understand how it works. We understand it, but it's much easier to control semi-reactors than the full reactors. We have developed, as you can see, as it can be seen, reactors which are literally a replica of what we have. So we achieve motion. We don't burn fuel. We increase the magnetic fields of our system. The magnetic field goes beyond the boundary of the reactor. If you put a coil around it, like a generator, as our system is dynamic magnetic field, in cutting the atoms of the copper winding of the coil, we create energy. The same way as at the moment the power stations burn the fuel to create the steam, to run a turbine, to create a rotating magnetic object, what we call a rotor, which has got magnets mounted on it within the generator to create electricity. Earth creates its own magnetic field. It has no steam generators inside, it has no turbine. But because of the magnetic positioning and gravitational positioning, it always rotates. In the book I have explained how even the rotation of the planet Earth comes about. Very simply, and we use the same principle in running our reactors. So, through understanding the construction of plasma, through understanding construction, the method the motion is created between the proton and electron, we have created the same technology. We don't burn fuel, but at the same time, the mass, which is magnetic field based, comes into play. That's why the mass is always constant for all elements. That is constant. If you are on Earth, proton has the same mass as you're on the moon. But the weight is different. So in the new system reactors, the mass is independent of what is outside the gravitational field of the reactors. So you can lift any mass independent of its position within the solar system, within the planetary system, within the galaxies. That's why we see the small core reactor of the Earth can move such a huge mass of the Earth for billions of years. A small amount of material within the core, and exactly this is how we have developed our reactors. The small reactors, we can reduce weight, we can increase weight, and we can move in any position because we don't burn fuel. We move away from it, that's not burning. We just position ourselves magnetically and gravitational. If you have magnetic field, you don't go anywhere. You have to have both gravitational and magnetic. And that's what we've done, and that's what we achieved.